At any time t seconds, the distance x meters of a particle moving in a straight line is given by x equals t over 4 minus log base e 1 plus t. Find, part 1, the initial velocity and acceleration. So remember that when you hear velocity in a maths paper, this means to differentiate. And when you hear acceleration, this means the second derivative. So we're going to differentiate. So x is equal to t over 4 minus log base e 1 plus t, which is the same thing as a quarter t, because t over 4 is a quarter t, minus log base e 1 plus t. So we're going to use one of our formulas from our formula book. So if f of x is ln x, so the natural log of x, then f prime x, the derivative, is 1 over x. So v, which stands for velocity, is equal to dx dt, the derivative of x with respect to t, which is equal to a quarter, so we just bring down this quarter, and minus log base e 1 plus t becomes minus, so the minus stays the same, 1 over 1 plus t. So that's using this formula here. And then we still have a quarter and a minus, and 1 over 1 plus t can be rewritten as 1 plus t to the power of minus 1. And this is going to be helpful for us when we want to differentiate again, because instead of a fraction with 1 over, it's better to have a power of minus 1, because this is better to differentiate. So in this slide, nothing's changed. I'm just showing how 1 over became to the power of minus 1. So that's from one of our powers laws. Okay, so now we want to find the acceleration. And remember that accelerate means differentiate the velocity, or basically find a second derivative. So x is equal to this. We worked out v equal to 1 over 4 minus 1 over 1 plus t, which we rewrote as 1 over 4 minus 1 plus t to the power of minus 1. So again, this is just a better way to write it. So a, which stands for the acceleration, is dv dt, which is the derivative of v with respect to t, so this being v. So the quarter has no t stuck onto it, so it's a constant, so we just cross it off, because remember, we're differentiating with respect to t. dv dt means to differentiate with respect to t. And then we have minus 1 plus t to the power of minus 1, and then we subtract 1 to that power. So remember, the rule for differentiation is bring the power down in front, reduce the power by 1. So the power was minus 1, and there was a minus already in front, so minus by minus 1 is positive 1, or just positive. So that's why we no longer have a minus here. And then minus 1 is minus 2. So the acceleration, which is dv dt, is equal to 1 plus t to the power of minus 2, which we're going to rewrite as 1 over 1 plus t to be squared, because again we're using our powers laws here, because it is better to have it as a fraction than a negative power. We only really use the negative powers when we need to differentiate, but it's better to write our answer, in this case our acceleration, as a fraction instead of a negative power. So we've 1 over 1 plus t to be squared. Okay, so we started with x, then we found v, the velocity, and then we found a, the acceleration. Now the question asks us find the initial velocity and acceleration. So the initial velocity is going to be when time is equal to 0 seconds. So initial velocity and acceleration means when t is equal to 0. So t is equal to 0, so we take the velocity v. So we have a quarter minus 1 plus t to the power minus 1. We swap that t for 0. So we have a quarter minus 1 plus 0 to the power of minus 1, which gives us a quarter minus 1 over 1, which is going to be minus 3/4 meters per second. And there's a minus 1, the power is minus 1 for velocity, so meters per second. So we do the same now with the acceleration, which was 1 over 1 plus t to be squared. So t is equal to 0, so a is equal to 1 over 1 plus 0 to be squared, which gives us 1. So it's 1 meter per second squared, and the power minus 2 stands for acceleration. Part 2. The time when the velocity is 0. So all we have to do is let v be equal to 0. So we put the velocity equal to 0 and we solve for t. So the velocity, which we worked out in part 1, is a quarter minus 1 over 1 plus t. We let that equal to 0. So we take the minus 1 over 1 plus t, we bring it over the equal sign, and it becomes positive 1 over 1 plus t. So we have a quarter equals 1 over 1 plus t. We cross multiply. So we have 1 multiplied by 1 plus t is 1 plus t. Bring down the equals. 4 times 1 is 4. Solve for t. Bring the 1 over the equal sign. It becomes minus 1. So t is equal to 3. So the time when the velocity is 0 is 3 seconds. Part 3. Find the acceleration when the velocity is 0. So we sub 3 into the acceleration, which we worked out in part 1. So in part 2, we worked out that t was 3. So it was 3 seconds when the velocity was 0. So we want to know what the acceleration is when the velocity is 0. So we sub 3, which we got from part 2, into the acceleration. So A stands for acceleration. So 1 over 1 plus 3 squared gives us 1 over 16. So the acceleration when the velocity is 0 is 1 over 16.